Hello, I'm Walter Grayman representing the Environmental and Water Resources Institute, that's EWRI's WDSA History Project. The purpose of this project is to document the history of water distribution system analysis. An important part of this project is a series of interviews with engineers, modelers, researchers, and practitioners who have made significant contributions to the field of water distribution system analysis. Our interview today is with Lee Cesario. Lee has been active in the area of water distribution system analysis since the 1970s. Almost his entire professional career was spent with Denver Water until his retirement a few years ago. His early involvement with network modeling, his many activities at the American Waterworks Association, AWWA, and his authorship of the book Modeling, Analysis, and Design of Water Distribution Systems resulted in Lee being the primary face of water distribution system modeling in the water utility arena for many years. This interview is being conducted via Skype on August 12, 2012. Lee, you've been working in this area for 40 years or so now. How did you first get started?
Hi, Walter. Thanks. It's a pleasure to talk with you. I began working for Denver Water in 1972 as a draftsman creating 200-foot maps. Well, these were maps that were drawn at a scale of 1 inch equals 200 feet. I would call them 200-foot maps. And these maps showed water distribution facilities and real estate. And then I transferred to the hydraulics section in 1973 and became involved in computer modeling and system measurements, such as demands, pressures, flows, and C values. And at this time, Denver Water was growing. We needed to do two things. First, we needed to modify our master plan that defined facilities, sizing, general location, and estimated cost of facilities to serve demands at certain points in time in the future. In the past, we had hired Black & Veatch, and Black & Veatch did a good job developing long-range master plans for us just about every 10 years or so. But Denver was growing, and we needed to do some of this work in-house on a more regular basis. So we wanted to modify the master plan ourselves and keep it up to date. Second, the Board of Water Commissioners adopted a participation policy that essentially said growth should pay its own way rather than existing customers or ratepayers. So we needed to size, locate, and determine cost of facilities necessary to serve growth. This information then became part of a participation agreement between Denver Water and the developer. So computer modeling was used to do both, modify the master plan and determine facilities for new development. But we also used it for operational studies, studies that would result in changes to improve the operation of the system. I remember sitting in a closet feeding punch cards via telephone line to a computer located in another state or somewhere. We would get the results the next day, and this was a costly and time-consuming process. And if there was an error in the data, such as a wrong pipe diameter or length, we would have to run it again. Or at least we would consider rerunning it or estimating what the new results would have been if we had the right data. And in the early years, we used the Ep Fowler program developed by Professor Alvin G. Fowler and his graduate student, Robert Ep, at the University of British Columbia. We traveled to Vancouver and met with Dr. Fowler and discussed the program. It was a Fortran program that we modified a bit, so we wanted to talk to him about it, and that would help us be able to make modifications to the program. And at the time, Chuck Howard just happened to be at the university at the same time, so we talked to him as well. And Chuck suggested we investigate a water system analysis program developed by Systems Control Incorporated in Palo Alto, California, and this program was called WATSIM. And it was developed using a federal grant and was also public domain. So while WATSIM was good because it could do extended period simulation, while the F. Fowler program produced a steady state solution. So we began using Watson and modifying it as well. We developed routines to compare calculated pressures and flows with measured pressures and flows, and to allocate demands to the nodes. So this was the beginning of my involvement in network analysis or computer modeling.
In the latter part of the 70s, I believe, Denver Water began a very ambitious and I think ultimately a fairly expensive program to develop a detailed model of their water distribution system. I guess originally, as you said, using Watson. As part of this effort, they've pioneered many advances, including use of GIS technology, calculation and spatial assignment of loads, and model calibration. Can you tell us about that experience a little?
Well, we knew that a computerized database that could be manipulated and automatically entered into the network model would certainly improve the efficiency and accuracy of the model, and therefore our ability to analyze the system. But data collection and compilation really became our most time-consuming effort. And we had lots of network data, but it was in various formats located in different places. We had pipe data on our 200-foot base maps, and we could calculate lengths based on those maps, and we had the diameters on the maps. And from our system measurement program, we had C values, pressures, flow rates over time, and even consumption for various types of customers. But demand allocation was difficult and time-consuming process, so we developed a routine to calculate demands and assign them to nodes. This routine was certainly crude and compared to what exists today, but it worked pretty well at the time. And we were able to rerun the allocation program for various times and conditions. But we also had an extensive SCADA system, system control and data acquisition system, that provided actual pressures, flows, pump rates, reservoir elevations, and so forth. So we developed a routine, computer routine, to extract the actual data from the SCADA system. So we used these data to define the network and help calibrate the model. We developed routines to automatically extract and compare the models with measurements and with the SCADA data. So on a spreadsheet, we could easily see differences and then make adjustments to the model, and this certainly improved the calibration accuracy and the whole process.
It's fascinating when you compare that to what's being done today, how really closely it mimics what's being done, obviously in a lot more automated manner. You also were involved in AWWA.
In the 1980s, I think it was the 1980s, we created a special committee within Denver Water to investigate electronic mapping and information systems, or what would grow into GIS. Generally, we wanted to draw our 200-foot maps and be able to extract pipe diameters and lengths that could be input for the network model. So after traveling the country and studying various systems, we chose a company called Centercom in Sugar Land, Texas. Their system allowed us to draw maps and create the network database electronically. We called this our Mapping and Information Management System, or MIMS. It was an automated mapping and information management system, or as it was called, an AM/FM system. Not a radio, but a computerized database. So the mapping and information management system we created transformed our 200-foot maps into digital drawings that contained the network data we needed, but we also added other data, including data for reservoirs, pumps, valves, and elevations. Therefore, with all this computerization, our ability to compile network data and perform hydraulic analysis was much better. It was more efficient, more accurate, and of course, much faster.
Over the years, you've been very active in AWWA at many levels. In 1982, you were founding chair of a Computer Applications Committee, which is now called the Engineering, Modeling, and Applications Committee, and lead editor on the first edition of AWWA's M32 Manual on Distribution Network Analysis for Water Utilities. Can you describe some of your experiences with AWWA and its impact on the field of water distribution system analysis?
Well, I spent a lot of time in the 1970s studying, using, and developing network analysis models. And of course, I learned other people were doing the same. And I wanted to know more about what they were doing, so I developed a questionnaire, and I mailed this questionnaire to about 100 water utilities across the country. I wanted to know what others were doing, what software they used, what data they had available, whether they did the work in-house or through consultants or so forth. So there were a lot of questions. And I compiled the results and made the results available to those who participated. And then one day on a trip with my wife Susan, we stopped at a restaurant in Cheektowaga, New York, near Buffalo. I told her what I'd been thinking. I laid out a plan to establish a network analysis committee within AWWA. I wanted to bring together all the network analysis modelers and the developers. And my goal was to identify and learn about available software, but also to encourage new features and capabilities that could be used, of course, by utilities and consultants. And I was a member of AWWA and knew some of the Denver water people involved in the AWWA. Someone suggested I put together a proposal for a network analysis committee and submit it. So I did. The proposal was given to the Engineering and Construction Division. I remember making the proposal at their meeting. They were older, high-level engineering consultants who were primarily involved in design and construction. And I was a low-level worker with an idea. But they liked the idea and approved my proposal, and thus the Network Analysis Committee was formed. It was called the Computer Assisted Design of Water Systems Committee. People at the time who were on the committee and also worked on the M32 manual included Paul Brasher, Jim Buttle, Chuck Howard, Joe Crone, Ed Morey, Sandy Robinson, Shimshek Sarakella, Uri Shamir, Robert Topping, John Bellin, Tom Walsky, and Don Wood. This was a good group of professors, consultants, vendors, and utility people. And somewhere along the way, you also were involved in this too. We worked together on a lot of projects together. And then the next year, after the committee was formed, our committee sponsored a session at the annual AWWA conference. I think it was in Las Vegas. And thus began many years of sponsoring sessions, writing and delivering papers, conducting and sponsoring training workshops, seeking and promoting new features or capabilities of what we called network analysis. For me, this was the most beneficial part of the whole experience, since it allowed us to learn from each other and also to share our knowledge with others who could carry on. As time passed and computer capabilities grew, we sponsored numerous sessions at the annual conference, sponsored the first computer conference, updated the M32 manual, and became more involved in CAD, SCADA, GIS, and eventually water quality monitoring. So I think AWWA had a significant impact on the development and evolution of computer modeling of water distribution systems.
Your AWWA book on water distribution systems that was published in 1995 was the first book to treat this subject in a holistic manner. How did this book come about, and what are your feelings on its use in the field?
Well, there are a couple of aspects of my life that indirectly led to the writing of this book. My dream as a kid, being 10 or 12 years old, was to be a city planner. Modeling provided a tool for city planning, well, at least a small portion of city planning. And I was involved in review and approval of water facilities for all the new development in the Denver water service area. So I found myself doing, in a small way, what I dreamed of doing as a kid. And yes, I liked it. And then I went to college at night for about 10 years working on a degree in civil engineering technology at Metropolitan State College and a master's degree in public administration at the University of Colorado, Denver, and spent some time obtaining a Colorado professional engineer license. I had a wife and 3 kids at home, and I loved the work I was doing. I had a lot of energy, and more importantly, I was accustomed to the discipline and rigors of studying and writing. In 1983, maybe 1984, AWWA asked me to write what would become their first published book, and it was called Microcomputers for Water Utilities, published in 1986. A couple of years later, they asked me to update the book. Well, the book focused on network analysis, but there were chapters on water hammer, billing, SCADA, rate analysis, project management, and a few other topics. And the field had expanded so much, there was no way I had enough knowledge to address all of these fields. But I felt I could write a book about computer modeling. So we agreed I would write what would become Modeling, Analysis, and Design of Water Distribution Systems. And at the time, I had much of the information in my head, and I just felt the time was right, and I still had the discipline to do it. So I spent 1,000 hours of my own time at night, on weekends, using vacation and sick leave to write the book in about 1 year. And while this was not a Denver water project, most of what I knew, of course, came from or was related to Denver Water or AWWA. So over the years, I was involved in numerous education and training programs through AWWA, Dr. Sarah Kell at the University of Akron, and various other organizations. So based on comments received at these and other functions, it seemed the book was pretty well received and more widely used than I expected at the time. And AWWA said it was their best-selling book for a couple of years. So it felt good knowing the book was used and seemed to be a good contribution to the field.
In later years, your professional work and within AWWA morphed into the related kind of alphabet soup fields of CAD, SCADA, AMF, and GIS, model calibration, and real-time modeling. Can you talk a little bit more about your experiences in the evolution of these fields?
Well, I touched on it a bit earlier, but basically one thing led to another. We started with basic network analysis methods and moved on to more highly sophisticated methods, and along the way created computerized databases, utilized the SCADA system, and developed routines for demand allocation and calibration. And it was computers that made this possible, and Denver Water was interested and willing to help us do this. So the field has since become considerably more sophisticated and provides an integrated analysis and design process for a variety of tasks that we only imagined back then.
Lee, in the early years of water distribution system analysis, you worked closely with a wide range of groups, academia, government, consultants, etc. You talked about some of the people that were served on your committee with you and on the development of M32. However, in recent years, there appears to be a widening divide between the research fields, primarily academicians and the practitioners at water utilities. Do you have any thoughts on how that schism has occurred and what can be done to encourage more interaction between researchers and practitioners?
Well, in the early days, I wanted to do modeling, and I wanted my utility to be in charge of doing the modeling, analysis, and design. But obviously, not all water utilities could afford to do this, nor did they want to. So at the time, there was a need for the model developer or programmer, the user, whether it be a utility or a consultant, researcher or academician who expanded features and capabilities. And also there was government funding that played a role. And often these functions overlapped, and many people were involved in multiple functions, of course. There were turf battles between vendors at the time. They wanted to sell their products. and they added features and capabilities to make their software better than others. The vendors wanted utilities to endorse their product and thereby say they had the best and most widely used. So there was intense competition. Reminds me of there was a time at one of our WWA conferences, I think it was Distribution System Symposium in Nashville, maybe 1992 or so. We gave network analysis modelers 30 minutes or so to say whatever they wanted to say about their product. I think we had 7 or 8 vendors, and it took a few hours to get through them all. But we thought it would be a quick, relatively quick way for utilities and consultants to hear about capabilities and features of current software. And it was, but one vendor was quite outspoken and derogatory of others. He created quite a stir, but while he may have alienated many people, I think it shaped the field in the long run. It had an impact on the people who were there and in the long run. So it seems to me that all parties should be working together for the common good, for the good of maintaining, designing, and building facilities that effectively and efficiently deliver good quality water at a fair price. I think that must be the water utility person coming out in me. So it seems to me, again, getting all the right people together and identifying common goals that benefit the parties involved would be a good thing. And, I don't know, maybe this is happening to some extent, but it could be that practitioners and researchers could get together again. Utilities could connect with local universities and identify needs. University, through graduate programs or classroom work, could help utilities define needs and then develop solutions. And this could be done on a local level or even on a broader national, even international level now. This would introduce people to the field and lead to improvements and expanded capabilities.
Do you have any other thoughts you'd like to add or share with us about your work in water distribution system analysis or the field in general?
Well, it was fun working with so many people in the business, consultants, professors, engineers, and water utility people from all across the country, and even some from other countries. We learned a lot from each other, and we were motivated, I think, by each other in many ways to do more and to improve the field. It was a group effort, definitely. I loved working in the field, and I'm glad I could make a meaningful contribution. I liked working for AWWA as a volunteer, and I really mean that. I liked working as a volunteer. And I am grateful to Denver Water and my boss for many years, Jack Davis, for giving me the freedom, opportunity, and support for 38 years or so. And it certainly has been a pleasure working with you, Walter, over many years on many projects. It's been a pleasure. Thank you.
Thanks very much, Lee.